Hi everyone, welcome to the Earth Science Regions Review podcast series created by Hommick's Middle School Earth Science Department. Today we're going to talk about page 7 in the reference table, the sedimentary rock chart. So this chart is actually broken up into 3 basic sections, okay, which we're going to get to in a second. And the nice thing about this chart, you have nice neat columns and rows that you can follow to get your information. The top section are all your clastic rocks. Rocks can be organized here by how big or how small the fragments glued together are going to be. Okay, so those are what your classic or fragmental rocks are. Below that are your crystalline rocks. These are made through the precipitation or evaporation of water. Next down you have your bioclastic rocks. They're going to be made from the dead plant or animal remains. Okay, and then limestone, you see here, okay, is actually fit into either category, crystalline or bioclastic. And we'll talk a little bit about limestone in a second. Okay, let's take a look at some of our categories that you're going to get information about. First off is texture, again, clastic, crystalline, or bioclastic, how the rock is actually going to form. Then you get your grain sizes. Grain size could either be size fragment glued together or size crystal with your crystalline rocks. Composition is going to be important because it's going to tell you the mineral or minerals that make up an individual rock. The comments, very important because it tells you a little bit of distinguishing characteristics about that rock. Then you have your rock name. And then finally a map symbol. Okay, let's take a look at each individual rock. Your conglomerate is a classic rock. The thing is about conglomerate is that it has a multitude of particle sizes that get glued together. But the big thing about it, they're rounded, which indicates that those fragments have been traveling for a long amount of time. You compare that with breccia, same exact type of rock as conglomerate, except now your particles are glued together, even though they're a huge multitude of sizes. Okay, it's going to be angled, which means those particles have not traveled a very big distance. Then you get to sandstone, and you get to siltstone, and you get to shale. And those actually give you grain sizes with actual centimeter values. So you can see, for instance, shale, for instance, has clay size fragments less than 0.0004 centimeters. You notice that your composition of all 5 classic rocks are polymineralic. Polymineralic just very simply means they're made up of multitude or many minerals. Below that you get your crystalline rocks. And these rocks are what we call monomineralic. It means that their composition is only made up of one mineral. So you get rock salt, rock gypsum, which is made up of gypsum, dolostone is made up of dolomite, and finally limestone, which is made up of calcite. Those are all monomineralic rocks. And you notice in the comments, they're made up of crystals from chemical precipitates and evaporites. So made through the precipitation or evaporation of water. Now, limestone is kind of a unique rock because it can either be made through the precipitation of water or it can be made through cemented shell fragments, which leads me to our next category of bioclastic rocks. Limestone and bituminous coal. They're going to be the 2 rocks that are going to be made from either the dead plant remains or the dead animal remains. So again, very, very easy chart to read. Really look at the comment section because that'll give you a lot of information. Okay, thanks so much. We'll talk to you soon. Bye.